Today, we're going on a little journey. We're going to follow a machine learning model from start to finish. We'll pull back the curtain on how a computer can go from looking at a bunch of messy data to making some incredibly smart predictions. And you'll see it's less about magic and way more about a really logical, step-by-step process. You know, it all starts with a question, just like this. Is it just a lucky guess? Some kind of weird digital wizardry? Well, the answer is a big, fat no. It's actually a very deliberate process, a journey that's powered by this whole world of machine learning. At its very heart, machine learning is just what this says. It's the science, and I'd say the art, of teaching computers to learn directly from data, instead of us having to sit down and write code for every single possible thing that could ever happen. Think of it this way. You know what a cat looks like because you've seen a ton of them in your life, right? Well, machine learning works on that exact same idea. We just show a computer millions of examples until it learns to spot the patterns all by itself. So what does it actually mean for a machine to learn? It sounds kind of out there, but we can break it down into a really simple, clear framework that pretty much defines the whole process. Okay, so this whole learning thing really just boils down to 3 parts. First up, you have the task, or T. That's what we want the computer to do, like figuring out if an email is spam. Next, you need experience, E. That's the data it learns from, like a huge database of emails that people have already marked as spam or not spam. And finally, there's performance, P. That's how we keep score. You know, what percentage of emails did it get right? And that's the fundamental loop of machine learning, right there. The system is designed to get better at its task by learning from experience, and we know it's getting better by measuring its performance. This simple cycle is the engine that drives this whole thing forward. So, the machine's experience is its data. But here's the thing. You can't just dump a bunch of raw information into a model and hope for the best. It needs to be carefully prepared and cleaned up, because this data is basically the high-octane fuel for the entire journey. All right, let's make this real. Instead of talking about spam filters, we're going to use a super famous dataset about iris flowers. Our task is to teach a computer to tell the difference between 3 very similar flower species just by looking at their petal and sepal measurements. And boom, right away you see the reality of most data. It's messy. See those question marks? That means we're missing information. This is totally normal, but a computer model just can't work with data like this. It really shows you why the very first step of our journey is so incredibly important. This workflow here shows you the whole picture. The actual learning part, what we call data mining, is just one piece of the puzzle. Honestly, most of the time and the hardest work happens before that, in the cleaning stage, and after it, when you're trying to figure out what it all means. So that pre-processing step is absolutely critical. It's where we deal with those missing values and also where we find outliers, data points that are so weird they're probably just typos. It also means we figure out which pieces of information, like petal length or petal width, are the most important. It's all about cleaning the fuel before we even try to start the engine. Okay, our data is clean, it's prepped, it's ready to go. Now it's time for the model to actually learn. You can think of this whole phase as the model's big study session. This quote right here, it captures probably the single most important idea in this entire phase. I mean, think about it. If you test a student on the exact questions from their notes, you only find out if they memorize the answers, not if they actually learned anything. The same exact thing is true for our models. So to make sure our model isn't just memorizing, we split our data. We take a big chunk of it, the training set, and we let the model study it to find patterns. But then we take a smaller, separate chunk, the test set, and we hide it. We keep it under lock and key. The model never, ever gets to see this test data while it's studying. So what is it actually learning? Well, it's building a set of rules from all that training data. It might learn that if a petal is really short, then it should check how wide the petal is. By looking at thousands of examples, it builds this complex web of if-then rules that help it tell the different flower species apart. The study session is over. The model has learned its rules. Now, it's time for the final exam to see if it actually understood what it was supposed to learn. This is the moment of truth. We're going to pull out that test set we hid away earlier. Since the model has never seen this specific data, it can't just rely on memory. It has to actually apply the general patterns and rules it learned during training. And the result for our little iris model? A whopping 96% accuracy. That's our performance metric. It means that on data it had never, ever seen before, it correctly identified the flower species 96 times out of 100. That is a fantastic grade on its final exam. And this is so important. It isn't magic, and it's not perfect. The model gets almost everything right. But notice that last row. It made a mistake. It predicted one flower was a versicolor when it was really a virginica. That's totally normal. These models work on probabilities, not absolute certainty. Okay, so we've gone from a simple question to some messy data to a trained model that's pretty darn good at identifying flowers. But why does this one little example matter so much? Because the journey we just followed, defining the task, cleaning the data, splitting it, training the model, and then testing it, that is the fundamental blueprint for almost all of this kind of machine learning. It's a repeatable, incredibly powerful process. The journey of our little flower model is, at its core, the very same journey taken by the massive, complex models that shape our digital lives every single day. When your bank flags a transaction that looks a little suspicious, it's because a model, trained on millions of past transactions, spotted a pattern. When Netflix suggests a movie it thinks to love, it's using this exact same process on your viewing history. It's the same journey, just a different task and a whole lot more data. So understanding this journey really unlocks the power of modern AI. It's not about magic, it's a logical process of learning from experience, which kind of leaves us with one last fascinating question. Now that we know how to teach them, what's the next big problem you think we should teach them to solve?